discuss let us discuss. Already we have given a detailed description about the azimuthal quantum number. The azimuthal quantum number gives the position of an electron in a subcell and is represented by small l, and the value of L is calculated by using a very simple mathematical formula. Very simple, easy to understand a mathematical formula. L is equal to 0 to n minus 1. L is equal to 0 to n minus 1. That is, L depends upon n. That means azimuthal quantum number depends upon your principal quantum number. Hence, in the mathematically we can represent it. L is the function of n. L is the function of n. When n changes, L changes accordingly. Let us discuss in detail. For first cell, K cell, n is equal to 1. K cell, n is equal to 1. L is equal to 1 minus 1 is equal to 0. For second cell, n is equal to L is equal to 0, 1. Because our starting number is 0 to n minus 1. Hence, we have to first write 0 and then other numbers. For the third cell, that means K, L, M cell, L is equal to 0, 1, 2. For fourth cell, L cell, L is equal to 0, 1, 2 and 3. In mathematics, our common knowledge, it is evident that 0 has no meaning. 0 has no meaning. But in chemistry, especially in the quantum number, it has a definite value because these numbers are the codified number, are the code numbers. These numbers are code numbers. Let us explain what is the meaning of these code numbers. L is equal to 0 means it is S subcell. L is equal to P means it is P subcell. L is equal to 3 means L is equal to 0 means S subcell. L is equal to 1 means P subcell. L is equal to 2 means D subcell. L is equal to 3 means it is F subcell. That is, there are a maximum number 4 subcells in an atom, namely S, P, D and F. 4 subcells. Maximum number of 4 subcells available in the atom. The S stands for sharp, P stands for principal, D stands for diffuse and F stands for fundamental. These are the full term explanation of abbreviation of these terms. This is the meaning of code numbers. 0 means S subcell, 1 means P subcell, 2 means D subcell, 3 means F subcell. If you write L is equal to 0, we have to understand that electron present in S subcell. If you write L is equal to 1 for an electron, we have to understand that electron is a P subcell. If you write L is equal to 2, we have to understand that electron is present in D subcell. If you write L is equal to 3, we have to understand that electron is present in F subcell. F subcell. These are the full term explanation. Similarly, like energy error among different cells, similarly there is also energy error different among different subcells. That is, S energy error is S is less than P, is less than D, is less than F. S is less than P, less than D, less than F. The energy of S subcell is lowest and F subcell is highest. F subcell is highest. Then let us discuss the maximum number of electrons in a subcell. The maximum number of electrons present in subcell is equal to 4L plus 2. 4L plus 2. Let us calculate the electron for the S subcell. For the F subcell, value of L is equal to 0. Then we put L is equal to 0. Then maximum number is 2. That means in S subcell, the maximum number of electron that can be present is equal to 2. Let us discuss P subcell. For P subcell, the value of L is equal to 1. Now we put value of L is equal to 1. Then maximum number of electrons is equal to 6. That means in P subcell, maximum number of 6 electron can be resided. For let us discuss for D subcell. For D subcell, value of L is equal to 2. Then we put value of L is equal to, then maximum number of electron is equal to 4 into 2 plus 2 is equal to 10. Is equal to 10. That means in D subcell there are maximum number of 10 electrons can be present. 10 electrons can be present. Let us discuss F subcell. For F subcell, value of L is equal to 3. Then 4 into 3 plus 2 is equal to 14. That means in F subcell, maximum number of 14 electrons can be present. In F subcell, maximum number of 14 electrons can be present. These are the maximum electron carrying capacity of the subcell. That is, F subcell can maximum carry 2 electrons, P subcell maximum carry 6 electrons, D subcell maximum carry 10 electrons, and F subcell maximum carry 14 electrons. These are electron carrying capacity of different subcells. Hence, this is all about the azimuthal quantum number. The azimuthal quantum number describes in details the position of the electron in subcell and how to calculate the subcells in a cell and the maximum electron carrying capacity of the subcell, as well as energy error among different subcells. This is all about the azimuthal quantum number. Now let us discuss the magnetic quantum number, the third quantum number in the quantum number serial. It is the third quantum number in the quantum number serial. The magnetic quantum number. Magnetic quantum number explains the position of an electron in subcell or in a orbital. The position of the electron in an orbital, and is represented by small m, and it is represented by small m. This gives magnetic quantum the position of the electron in a subcell or an orbital, and is represented by small m. The value of m is calculated by using mathematical formula. Likewise, your azimuthal quantum. The value of m is calculated from minus L to plus L through 0. Value of m is equal to from minus L to plus L through 0. That means the value of m is dependent on L. That is, magnetic quantum number is dependent on your azimuthal quantum number. Magnetic quantum number is dependent on your azimuthal quantum number. That is, mathematically we can write m is the function of L. Let us discuss for S subcell L is equal to 0. We know for S subcell L is equal to 0, then m is equal to 0. For P subcell L is equal to 1, m is equal to minus 1, 0, plus 1. That is, P subcell has 3 orbitals. P subcell has maximum 3 orbitals. For D subcell L is equal to, m is equal to, we can calculate m is equal to from minus 2, minus 1, 0, plus 1 and plus 2. M is equal to minus 2, minus 1, 0, plus 1 and plus 2. That means the D subcell has 5 orbitals. D subcell has 5 number of orbitals. Let us discuss F subcell. For F subcell, L is equal to 3. For F subcell, L is equal to 3. M is equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. L is equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. That means the D subcell has 7 orbitals. The D subcell has a maximum number of 7 orbitals. We conclude that the S subcell value of m is 0. Already we have told that In quantum number, 0 has a definite meaning because it is a code number. That means the S sub cell, 0 means S sub cell has only one orbital. The S sub cell has only one orbital. The P sub cell has 3 orbitals, and D sub cell has 5 orbitals, and S sub cell has 7 orbitals. F sub cell has 7 orbitals. Let us calculate the maximum number of orbitals in a subcell. The maximum number of orbitals, in a subcell is equal to 2L plus 1. The maximum number of orbitals in a subcell is equal to 2L plus 1. This is a very simple mathematical formula to calculate the number of orbital in a subcell. The maximum orbital in a subcell is equal to 2L plus 1. And now we will discuss how to calculate the maximum number of orbitals in a subcell by using this simple mathematical formula.